So this is the National Instruments MyRio, which acts as the hub between the hardware and the software of the entire system. We have this breakout board here, which takes all of the digital input-output pins and breaks them out for each of the individual coils. And we have op-amp buffers to make sure that we're not blowing any of the pins on the MyRio itself. And then we also have 15 volts that gets inputted into this, which then gets daisy-chained down the line to all of the other boards for a secondary power supply. So this is the charging board, which acts as the intermediary between the power supply, the capacitors, and the coils themselves. It has two modes to it, charging mode and fire mode, which defaults to charging mode, which uses a current limiter to limit current out of a power supply set for 50 volts to 1 amp so we can charge up the capacitors. And when the capacitors reach about 47 volts, then a Zener diode breaks down and we illuminate a diode here so that we can see when it's all ready to fire. And then using logic on the MyRio, you can change it over to fire mode, which then pulls current out of the capacitors, 20 amps, and sinks it into the coils themselves. There's hardware logic on here to make sure that the board is not in charging mode and firing mode at the same time, so we can protect the power supply and the capacitors themselves. So these right here are the coil control boards. We have 10 of them, one for each of the 10 stages of coils that we have. These coils have about 8 layers, nearly 400 turns on them, and IR sensors right before each coil. So when a projectile comes through, it trips the IR sensor, and then that sends logic to the board, back to the MyRio, which then tells the MyRio to turn on, which then turns these transistors to turn on and sync 20 amps from the capacitors into the coil. And it's doing that the whole time that it's being blocked, and then as soon as it's no longer blocked by the IR sensors, it turns this coil off and begins to turn on the next one when it trips that IR sensor. That way we only have one stage on at a time, and the projectile gets accelerated as it goes down the line instead of going to the middle of any of the magnets. A couple of extra boards just to make sure that the whole system plays nicely. This one right here is the coil control breakout board, which takes in voltage and current from the capacitors here, actually from the charging board, and then sends it out to all 10 of the different coils. Using the logic on the coil control boards, only one of these is on at a time. And then also over here we have our velocity sensing board, which uses 2 sets of IR sensors to calculate the speed of the projectile when it's exiting the barrel, and that is displayed down at the end on an LCD screen, which tells you the speed of the projectile in meters per second. Okay, so these are the steps required to fire the projectile. We're going to go ahead and turn the power supply on, which begins to draw 1 amp and put it into these capacitors through the charging board. It takes a couple of seconds the first time to charge up, but once this green light comes on, that's when we know that we're at 47 volts. So now we're all ready. We'll put the projectile in right here, and then pressing the button on the MyRio for it to go. Now it's in fire mode, and then